2010 Projectiles question 3A. In a room, height 6 meters, a ball is projected from a point P, and P is 1.1 meters above the floor, and you can see that in the diagram here. The velocity of projection is 9.8 root 2 meters per second at an angle 45 to the horizontal. So my initial vector is going to be 9.8 root 2 cos 45 I plus 9.8 root 2 sine 45 times j. And actually the root 2's will cancel there, won't they? That's going to be 1 over root 2. So it's going to be 9.8 in the I direction plus 9.8 in the j direction. We can also see here the distance traveled in the j direction. It's from here to here. So 6.6 minus 1.1. 6 minus 1.1 is equal to 4.9 in the j direction. So that's my displacement in the j direction is equal to 4.9. So I use ut plus a half at squared. I'm going to get 9.8 t, so I can find the time taken to get there. And that will be minus 4.9 t squared will be equal to the displacement 4.9. Well, I can bring these across and divide by 4.9, so I'm going to get t squared minus 2t plus 1 equals 0. So that's t minus 1 to be squared. Yeah, that's right. So t is equal to 1. So it's going to take 1 second to get there. We're asked to find, I didn't read the last part, the ball strikes the ceiling, you cue it out for striking a wall. Find the length of the straight line PQ. Okay, let's do a little diagram for that. So here's P and Q. We have this direction here, 4.9, or this distance of 4.9. So we need this direction here. We call it X, we call it I, and then that will enable me to use Pythagoras. So simply enough here, then how far does it travel in the S direction or in the I direction? It's just going to be ut. The u is 9.8, the t was 1, so that's just 9.8 meters, 4.9 meters. So PQ is equal to the square root of 4.9 squared plus 9.8 squared. So PQ is equal to, typing this into a calculator, 10.96 meters.